Alrighty guys, so the first problem I had for Chapter 4 Bingo was 4.1, and the question says that two dogs are pulling horizontally on ropes attached to a post. The angle between the ropes is 60 degrees. If Rover exerts a force of 270 newtons and Fido exerts a force of 300 newtons, find the magnitude of the resultant force and the angle it makes with Rover's rope. So I think the easiest way to kind of look at this is we kind of draw a little diagram right here. Right here is our post. We have Rover as this vector right here, exerting a force of 270 newtons, and Fido as a vector right here, exerting a force of 300 newtons, and the angle between Fido and Rover, the angle between those two vectors, is 60 degrees. And so now what we're trying to find in this problem is what is the magnitude and angle of the resultant vector that forms between from Rover's position. So to find this, we kind of just treat this like we would from Chapter 2, dealing with vectors. And so to do that, we need to find the x and y components of each vector and add those together and all that other stuff. So that's what we're going to do right now. So we're going to say the x component of Rover is equal to his, basically this time it's just going to be the 270 newtons, since Rover acts as our x-axis. And the y component of the Rover vector is, in this case, just equal to 0, since it's just going straight across, acting as the y component. And then for Fido, our x component for Fido is equal to the magnitude of the vector times the cosine of the angle between Fido and Rover. And we use cosine because cosine gives you the x value of a point along the unit circle. Just kind of a little background on that one. So that, when you do that math, that ends up coming to 150. And then the y component of Fido is again equal to the magnitude of the vector, the 300 newtons, times the sine of the angle between the two vectors. And again, just going back to the unit circle, you use sine because that gives you the y value of your point along the unit circle. If we were to look at this as just a simple triangle. So then when you do that math, that comes out to be 260. And then the next step to find the magnitude of our resultant vector right here, that's going to be magnitude is equal to, we remember from Chapter 2 dealing with the vectors, that equals to your x component squared plus your y component squared. And so that's going to be your x components of each vector added together, quantity squared, plus your y components, quantity squared. And then that, I'm just going to come down here, that comes out to be roughly about 464 newtons when you add all these together, square them, and then square root them. And then to find the angle that your resultant vector makes with your x-axis, you can remember from trig that tangent theta is equal to y over x. So then to find your theta, you take arctangent of both sides. A tan is equal to y over x. A tan is equal to your total y vectors, which we know is 260, over your total x components, which comes out to be 420. And you can simplify this down until it becomes your arctangent of 13 over 21, and then you just plug that into your calculator and you get 31.8 degrees as your theta. And so there you have it. That is 4.1.